Okay, with this new section, we have a title that is almost as long as the whole section. It's the relationship between electric potential and electric fields. And the first thing we're looking at here is the work done by an electric field. Well, the work done by an electric field is just the negative voltage times the charge. Why is that? Where did that come from? Well, we solved in the last section for our change in potential energy and our change in electric potential energy. Well, it's just going to be the opposite of the work. Remember, the amount of energy that we're losing in electric potential is the work done by the electric field. So it's just going to be the negative sign of that. So let's try a problem out with it, and we'll see if we can solve for it. So this will be number 6. I'll just come over here and draw them. I've got 2 plates. Positive, 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 positive. I got a plate over here. Negative, 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 negative. The difference in voltage between the sides, so our delta V is equal to 50 volts. Doesn't matter what they are. And what each side is, it just matters the difference. And the separation is 5 centimeters. I want to know, so for part A, find the electric field between the plates. And I'll remind you, the unit for electric field is newtons per coulomb, but it can also be written as volts per meter. Hopefully that hint is very useful. Take a second, try and solve for it, and we'll be right back to go over it. Hopefully you picked up on that cue. Right here we have that our voltage is just equal to the electric field times how far across it goes. You may see it written as R or D. I just want to get you exposure to both. It really doesn't matter. Remember, D and R both are just measuring a distance. So when we rearrange this to solve for electric field, it's just volts over distance, which makes sense, volts per meter. So 50 volts is our change. Our distance between them is 5 centimeters, so we end up with a voltage of 1,000 volts per meter. And now for part B, I want you to know if the plate, if the positive plate, my apologies, is plus 100 volts, what is the voltage 2 centimeters to the right of it? Hopefully your answer to part A will make this very easy to solve for. Try not to overthink it. It's very simple if you just think about units. So go ahead and give it a shot, and we'll be right back to go over it. Okay, hopefully you got 80 volts. The way we did this was, we know the electric field strength is 1,000 volts for every meter we go. That means for every 1 centimeter we go, it's only going to be 10 volts because that's 1/100th. If we're going 2 centimeters, that'll be 20 volts. So look, we just take the electric field times how far we go through it, and we end up with our voltage change. We drop 20 volts because remember, we're going from positive to negative. So if I lose 20 volts, 100 minus 20, I end up with 80 volts for it. And that's all we have for this section.